Hello again, welcome back to Math 0332 videos. I'm Mr. Lee, and we're picking up in the middle of the section on word problems. I will help you set up 7 and 8. I'm less worried about solving them, more than I am worried about making sure you understand how percents convert. So if you have something like a bed costs $432 after an 80% price reduction, how much was the original cost? Let's call the original cost X. What does the price reduction represent? It represents subtracting. A reduction is like a subtraction in cost. So a loss of 80% price means you subtracted 0.8x. What this really means is that your bed is combined between those two. So x minus 0.8x equals the cost that you paid of $432. This is 1 minus 0.8. So really, when you have an 80% price reduction, that means 80% of the cost is reduced and that only 20% remains, which can be confirmed by doing 1 minus 0.8. You get 0.2x equals 432. Again, to get rid of decimals, what you can do is multiply everything by 10. So you'll get 2x. So let's draw this distributed to both. 2x equals 4,320. And then to solve for x, you can divide by 2 and say originally the price was $2,160. I think this means you got a pretty good deal, personally, but you can always get a different bed if you didn't have the money for that. But yes, beds are pretty expensive right now. I personally favor one that, has like cooling technology, but money being what it is, that's usually your primary restrictor. Now, a hotel costs $122.08 after a 9% sales tax is added. What was the original cost? This is really asking you, a price reduction reduces X. A sales tax adds X. So the hotel is going to cost X dollars, but then you pay tax, which is a relationship to X. It's 9% of X. So the tax is 0.9 or 0.09x if you convert your percent to decimal. Now, in life in general, what happens with tax? It's added to your bill. So that really means x plus 0.09x equals this 122.08, the total amount that you paid. Much like subtracting, 1 minus 0.8 left 20%, 1 plus 0.09 is 1.09x equals 122.08. Unfortunately for you, these are two decimals. These have 2 places behind the decimal, so instead of multiplying by 10, you'd like to multiply by 100 on both sides to get 109x equals 12,208. Big numbers, but on the bright side, no fractions. So when you divide by 109, you really hope this goes in relatively evenly. We'll do our old school division. How many times does 109 go into 1? No times. 12? No times. But 122, it goes in once. So we subtract off the 109. You get 13. Bring down the 0. How many times does 109 go into 130? Also once. Subtract the 109 to get 21. Bring down finally our last term, the 8. And you find out that 109 goes into 218 exactly twice. To subtract 218 leaves 0 at the end, which means there's no cents. There's no parts, no fractions left over. So what did the hotel cost before tax? The $112. Again, I'm not going to put those on the quiz or even on the midterm. We can deal with them a little bit more in the second half of the course. I just wanted you to be able to set them up while you can. Because in reality, most of what you're going to deal with in life deals with money. And so money deals with taxes or sales or price reduction, so it is important. Now the last part of this 5th homework isn't word problems. It's mainly about solving for variables when you've got a bunch of variables going on. This can be somewhat intimidating to students because they see all of the letters and they freak out a little bit. Now, your goal here is to recognize that all of these letters represent numbers, so whatever you do to try to get one of these things by itself, it would be the same things you would try to do to get a variable by itself if those things were all numbers instead. For example, let's look at number 1. Area equals length times width times height. That's not even actually an equation, but we'll call it volume, just because volume is actually of like a box, is length times width times height. So at least we can use an accurate formula. Now, what if I look at this equation, I try to ask myself, I'm getting W by itself, so I need to unwrap it, which means whatever was done to W by the other variables on its side, I have to undo by doing the opposite action. So right now, width is multiplied by length and multiplied by height. And to undo multiplication, you divide. So right now, I can divide by both of these at the same time. Think about if it was 2 times W times 5. What you would do is you would combine them and call them 10W, and then to get W by itself, you'd divide by 10. So I'm pretending L and H got multiplied together, and now they're in front of W, and I'm getting rid of them both at the same time. Now, that gets our W by itself. On the other side, there's nothing really to solve because everything's a variable. There's nothing to combine. They're all different. And we don't have any actual numbers, physical numbers to deal with, so this is really all we can do. But this does get W by itself, which is the whole goal of these questions, is to say what W would be equal to if it were by itself. The reason that you might ever want to do this is that if you're given numbers for length, height, and volume, it becomes very easy to plug it in because W is already by itself. I'll leave number 2 for you to do. One thing to note is to cancel a 1/2. You either divide by 1/2 or I prefer multiply by 2. Because 2 times 1/2 is 1, so we'll make a little note of that. So to get rid of the 1/2, you'll multiply by 2, but otherwise your strategy to get it B away from H is exactly the same as here. Looking at y equals mx plus b, the equation of a line, our goal again is to get m by itself in this equation. Now right now m is multiplied by x and then b is added to it, so to undo this we go in the opposite order, which starts by subtracting b from both sides to get y minus b equals m times x. Now the only other thing happening to m is it's multiplied by x, so to undo we'll divide. And since these are all variables, I'm going to put the m on the left, but you don't have to. It's just y minus b over x. There's nothing else there except to box your answer. And I will let you, as well as besides trying 2, try 4. And this is really the end of Unit 3 Homework 5 notes. We'll have one more homework section left, and then we'll be done with Unit 3.